This conversation is powered by Google Illuminate. Check out illuminate.google.com for more. Today's discussion centers around a fascinating interactive physics simulation, Buoyancy Force on Mass JavaScript Simulation Applet HTML5. It's part of a larger collection of open educational resources, and it's designed to make learning about buoyancy more engaging. What initially drew you to this particular simulation?
The innovative use of JavaScript and HTML5 to create a truly interactive learning experience. It's not just passively reading about buoyancy. Students can manipulate variables and see the immediate effects. That's powerful.
Absolutely. It's a far cry from static diagrams in textbooks. The Applet allows for adjustments to mass, weight, and density. How effective do you think this level of interactivity is in enhancing understanding?
Extremely effective. By directly manipulating variables, students develop a deeper intuitive grasp of the relationships between mass, weight, density, and buoyant force. It's experiential learning at its best.
And the fact that it's embeddable in web pages makes it incredibly versatile for educators. Let's delve into the specifics. You mentioned the interactive nature. Can you elaborate on how the sliders and draggable elements contribute to the learning process?
The sliders allow for precise control over parameters, enabling students to conduct controlled experiments. They can systematically change the mass, for example, and observe how the buoyant force responds. The draggable hanging scale adds another layer of interaction, allowing students to explore the concept of equilibrium.
It sounds like a virtual laboratory. Does the simulation offer any guidance or instructions to help students navigate the applet effectively?
Yes, the documentation includes clear instructions on how to use the sliders, drag the box, toggle full screen, and reset the simulation. This ensures that students can easily engage with the tool without getting lost in the interface.
The simulation is categorized as an open educational resource, or OER. What are the implications of this classification for accessibility and educational equity?
OERs are incredibly important because they break down barriers to access. This simulation, being freely available, allows educators and students worldwide to utilize it regardless of their financial resources. It promotes educational equity on a global scale.
And the Creative Commons license further enhances this accessibility, allowing for adaptation and redistribution with proper attribution. This fosters collaboration and improvement within the educational community. Let's talk about the technical aspects. The use of JavaScript and HTML5 is key. What are the advantages of this technology choice?
HTML5 and JavaScript make the simulation accessible across a wide range of devices and browsers without requiring any plugins. This eliminates compatibility issues and ensures broader reach. It's a modern and efficient approach.
Who is the intended audience for this simulation? Is it geared towards a specific age group or educational level?
Primarily, it targets students learning about forces, moments, weight, density, and buoyancy. It's adaptable to various educational levels, from secondary school to introductory college physics. The interactive nature makes it suitable for diverse learning styles.
How effectively does the simulation demonstrate Archimedes' principle?
Archimedes' principle is implicitly demonstrated through the interactive manipulation of variables. Students can observe how changes in an object's density relative to the fluid affect whether it floats or sinks. This provides a visual and interactive understanding of the principle.
Beyond buoyancy, are there other applications or extensions of this simulation that you envision?
Absolutely. The underlying principles could be extended to explore other fluid dynamics concepts, such as pressure and fluid flow. The framework could also be adapted to simulate different fluids and objects.
The website features numerous other interactive simulations. How does this particular buoyancy simulation compare to others in the collection?
While the other simulations cover a wide range of physics topics, this buoyancy simulation stands out due to its clear focus, intuitive interface, and the direct manipulation of key variables. It's a well-designed and effective tool within a broader collection of valuable resources.
How could educators effectively integrate this simulation into their lesson plans and assessments?
It can be used for pre-lab activities to build intuition, during lab sessions as a virtual experiment, or as a post-lab activity to reinforce concepts. Assessments could involve predicting outcomes based on parameter changes or explaining observed phenomena.
The study guide included a quiz and essay questions. How valuable are these supplementary materials in maximizing the learning potential of the simulation?
The quiz and essay questions are crucial for formative and summative assessment. They encourage students to reflect on their experiences with the simulation and articulate their understanding of the underlying principles.
Are there any limitations to the simulation or areas where it could be improved?
While the simulation is excellent, incorporating more realistic fluid dynamics, such as viscosity and turbulence, could enhance its accuracy and realism. Adding more complex scenarios, such as multiple objects interacting, would also increase its educational value.
What about the potential for incorporating AI or machine learning to personalize the learning experience?
AI could personalize the difficulty level, provide targeted feedback, or even generate customized problems based on a student's performance. This would create a truly adaptive learning environment.
The simulation is part of the Open Source Physics at Singapore project. What is the significance of this broader context?
The project's comprehensive nature is significant. It provides a rich ecosystem of resources, fostering collaboration and the development of high-quality educational materials. This collaborative approach benefits both educators and students.
Let's address some frequently asked questions. The FAQ section clarifies how to access and embed the simulation. How important is this ease of access for widespread adoption?
The simple iframe embed code makes integration seamless. This ease of use is crucial for widespread adoption as it removes technical barriers for educators.
The FAQ also highlights the subjects covered by the Open Source Physics at Singapore website. This wide range of topics is impressive. How does this breadth of coverage contribute to a holistic learning experience?
The breadth of coverage ensures that students have access to resources across various scientific disciplines. This interconnectedness helps students see the relationships between different areas of science.
The FAQ also addresses the licensing and technology used. How important is it to clearly state the licensing terms and the technologies used?
Transparency regarding licensing is crucial for legal compliance and encourages responsible use. Clearly stating the technologies used helps educators understand the compatibility and potential limitations of the simulation.
Finally, the FAQ mentions the creators of the simulation. How important is it to give credit to the developers?
Giving credit is essential for acknowledging the effort and expertise involved in creating the simulation. It also encourages further development and collaboration within the open source community.
Considering all aspects of the simulation, from its interactive features to its open source nature, what is its overall impact on science education?
The simulation has the potential to significantly enhance science education by making learning more engaging, accessible, and equitable. Its interactive nature fosters deeper understanding, while its open source nature promotes collaboration and widespread adoption.
This discussion has highlighted the many strengths of the Buoyancy Force on mass JavaScript Simulation Applet HTML5. Its innovative design, accessibility, and potential for integration into various educational settings make it a valuable tool for enhancing science education. Thank you for sharing your expertise.
Thank you for the opportunity.
That was a great discussion.